When people talk about nuclear power, they often repeat the same criticism. It's too expensive. And honestly, looking at some modern projects, it can be hard to argue otherwise. Some reactors have taken years longer than expected. Some have cost billions more than originally planned. Some became symbols of everything that can go wrong in large infrastructure projects. So the conclusion seems obvious. Nuclear power is expensive. Case closed. But what if that's the wrong question? What if the real question isn't, why is nuclear expensive? But instead, why do some nuclear projects become expensive while others do not? Because once we look at the evidence, the story becomes far more complicated and far more interesting. For years, public debates about nuclear energy focused on the reactor itself, the technology, the engineering, the physics. But when organizations such as the OECD Nuclear Energy Agency examined the economics of nuclear construction, they repeatedly pointed toward a different set of factors. Financing, risk, project execution, construction schedules, industrial capability, supply chains, and something called FOAK, first of a kind. In other words, the reactor might not be the whole story. Imagine building a completely new reactor design for the first time. Not the second, not the fifth. The first. Before electricity is generated, years of work happen behind the scenes. Designs must be finalized. Manufacturers must qualify components. Regulators must review systems. Workers must gain experience. Supply chains must learn new processes. According to OECD studies, these first projects often carry costs that later projects may not. Not because physics changes, but because experience does. The first airplane is usually harder to build than the 100th. The first smartphone is usually harder to manufacture than the millionth. And nuclear reactors are no exception. But there is another factor, one that receives far less attention: time. A nuclear power plant requires enormous upfront investment, long before it produces electricity, long before revenue begins to flow. Which means every additional year matters. A delay is not merely a scheduling problem. It can become an economic problem. Money remains tied up. Risks remain unresolved. Financing costs continue accumulating. And suddenly, a project that looked affordable on paper begins to look very different. Now consider two projects, two nuclear plants, built in the same century, using modern technology, designed to achieve the same goal: reliable, low-carbon electricity. Yet their outcomes look very different. Some projects progressed relatively successfully. Others faced years of delay and cost escalation. Why? The answer appears to involve much more than reactor technology. One of the most fascinating ideas found in OECD reports is industrial continuity. For decades, many countries dramatically reduced the pace of nuclear construction. At first glance, that may not sound important, but complex industries rely on something fragile: experience. Engineers retire, specialized suppliers disappear, skills fade, institutional knowledge weakens. And when construction eventually begins again, part of the challenge may not be building a reactor. It may be rebuilding the capability to build reactors. That raises an uncomfortable possibility. Some expensive projects may have been paying not only for construction, but also for years of lost industrial memory. Then there is financing, a subject that economists often find impossible to ignore. Imagine two identical reactors, same design, same engineering, same power output, but different financing conditions, different risk structures, different access to capital. From an engineering perspective, the reactors are identical. From an economic perspective, they may look very different, which leads to a surprisingly simple observation. The cost of building something and the cost of financing something are not necessarily the same thing. And this is where the story changes. Because public discussions often focus on the reactor, yet many of the factors identified by OECD research exist outside the reactor itself. Financing, risk allocation, project execution, construction duration, supply chains, industrial continuity, learning effects. None of these change nuclear physics, yet all of them can influence project cost, sometimes dramatically. Now, none of this proves that every nuclear project will succeed, and it certainly does not excuse cost overruns. The evidence does not support those conclusions. But it also does not support a much simpler claim: that expensive projects automatically prove nuclear technology is inherently expensive. Reality appears more complicated than that. So perhaps we've been asking the wrong question. Instead of asking, why is nuclear power expensive? Perhaps we should ask, why have some countries managed to deliver nuclear projects more effectively than others? Is the difference technology, financing, project management, industrial continuity, or some combination of all of them? And if the ability to build reactors can be lost, can it be rebuilt? Because the answer to that question may shape the future of nuclear energy far more than the reactor itself. This is Reactor Atlas, exploring nuclear energy through physics, not fear.